everyone. Today we are going to learn 6.2 spring problems, second part. Okay, so it continues from last section, spring problems, first part. Okay, so here we have a free, sorry, come on. Free vibration with the damping. So damping means there is a resistance, like air resistance or friction, right? And in the damping, we have formula, right? So we are using the first letter. So we are using the subscription F sub D. Yeah. And then we have a negative C Y prime, right? So if we have free, then negative C equal to 0. Motion is free. Did I say right? Oh, yeah. Damping, sorry about that. Damping, not damping, right? No damping, then C is greater than 0. Yeah. Okay, so damping, C is greater than 0, right? Okay, so in the damped force, we have under and we have a critical, we have over damping. Okay, so under, over, then critical damping. All right, so let's take a look. So we have this formula from previous section. Yeah, so we make the force equal to 0. That means free, right? Motion is free, then F equal to 0. Yeah. Okay, then M stands for mass, right? And then we have a coefficient of damping force, C y prime, plus K from the spring force, constant. Yeah. Okay, then if we have this form, my second prime plus cy prime plus ky equal to 0, then we can express as r squared, right? R squared r plus k equal to 0. And then we solve for r, right? Okay, then look, we are using quadratic formula, right? So minus b plus minus square of v squared minus 4ac all over 2a, right? So we following their coefficient here, right? So that will be a, b, c. So minus b, which is c, and plus minus. So in that case, minus first and then plus there, right? And then b squared, which is c squared, minus 4 times a times c. So 4 times m times k, right? All over 2 times 8, right? Which is m. Make sense? So this is from quadratic formula. Okay, now, as I said earlier, damping force, damped force, we have under, critical, over, right? So 3 types of damping force, okay? And then we have free vibration, yeah? Okay, now, let's take a look. Under. The first one is under, second is overdamped. Yeah. And the third one is critical. Make sense? Okay, let's compare. So if we have underdamped motion, that means oscillating with decreasing amplitude, right? So in that case, C is less than square root of 4mk. Yeah, can you see that? So this means the damping force is present, but it's not strong enough to prevent objects from oscillating, right? So oscillating, moving, shaking, right? Oscillating vertically like this. Vertically, am I correct? Horizontally? Yeah, right. Okay. All right. Then in that case, underdamped, right? So we have the root, two root, right? So there will be negative C over 2m minus I omega sub 1. Okay, other one is positive. Okay, then how do you find omega sub 1? Because C, M, that's a coefficient from the equation, right? Okay, then omega sub 1, omega sub 1 equal to square root of 4mk minus c squared minus, sorry, over 2m, yeah? Okay, then general solution will be y equal to e to the negative ct over 2m. And then we seen this one before, right? Okay, now overdamped. When c is greater than square root of 4mk, yeah? 4 times m times k. So what this mean? Overdamped, oscillating with increasing amplitude. So what this mean? This means when the damping force is so strong that the system takes a long time to return to its equilibrium position after being displaced. Yeah. Now we have solutions are real. This is a complex we had before, right? Because C is less than this one, right? Okay, so we have general solution form is like this. Okay, now we have a critically damped motion. C, when C equal to square root of 4 times m times k, right? So what this means? This means when the damping force is precisely adjusted so that the system returns to its equilibrium position as quickly as possible without oscillating, right? So without oscillating means steady oscillating. Okay? All right. So solutions R sub 1, R sub 2 equal to negative C over 2m. So general solution will be negative C2 over 2m, and the form is like this. Okay? All right, let's do this. Okay, we have this question. Suppose a 64 pounds weight. So this is a weight. Yeah, weight. So W. Yeah, so 64 equal to weight W. Stretch a spring 6 inches in equilibrium, right? And dashboard provides damping force of some C pounds for each feet per second of the velocity, right? Okay, now the first question says the right equation. Yeah. And then we want to find such C pounds, right? And then the motion is critically damped, right? Okay, if critically damped, we have to use C equal to square root of 4mk, right? Underdamped, C is less than square root over 4 times m times k, right? Overdamped, C equal to square root of C is greater than, sorry, C is greater than square root over 4 times m times k, right? Okay, so let us do this one. A. Okay, so we're gonna start with that equation beginning, right? Plus C y prime plus K y equal to 0. Okay, now what is the M? M, okay, note. M equal to weight. This is a mass, right? So mass equal to weight over gravity. Yeah, so there will be uh, W over G Where did this one come from? Because this one come from the formula weight equal to mg, right? Okay, that's why we want to solve for m, divide by g both sides, so m equal to w weight over gravity. Make sense? Okay. Now, because we want to know about the m first, and we need to find the source c. So critically damped means C equal to square root 2 of 4 times m times k, right? So we have to know what's m, what's the k. Yeah? All right. So m equal to weight over the gravity, right? So that will be weight, in that case, 64 pounds, right? Okay, what did I say? 64 pounds, right? Okay, over gravity, we want to express in terms of feet over second squared, right? Second squared, yeah. So 32 feet per square feet. Square feet, square second, right? Okay, all right. Then we call this one what? So 64 divided by 32, then we get 2, right? And then the unit, this unit we call the slug. So we have a S, slugs. So this unit, okay? All right, then we had earlier, previously, we had mg equal to delta k, sorry, k delta L, right? K delta L, which is the same as K delta the lowercase l, right? So then we solve for K now, right? So solve for K. So there will be divided by delta L both sides. So we have K equal to mg over delta L, right? Okay, mg, what do we get? mg will be 64. Okay, let me double check this one. Okay, so mg, yeah, this one. mg equal to what? Weight, right? So weight, yeah, I want to make a clear weight, not the omega, right? So weight, W, right? Over delta L, right? So weight, we have a 64 pounds over delta L. So let's take a look. So we have delta L 6 inches in equilibrium, right? So we had the experience in the previous section. We want to convert to the feet, then 1 feet corresponding 12 inches. So we have a 6 out of 12, which is 1/2 feet, right? So 1/2 feet. Am I recording? Yes. 1/2 feet, right? Okay, now, all right, so if we multiply 64 times 1/2, then we get 128 pounds per feet, right? Okay, now we had what is M, what is K, right? Now we want to solve for C. Yeah. Okay, there's the K. All right, so C. So since critically damped, so C equal to square root of 4 times M times K, right? So equal to square root 4 times M. M is 2 slugs, so 2. K is 128. Now, can you please calculate? So 4 times 2 times 128, and then we make a square root. Okay, we get the 32. Very good. Okay, so everything is good. So we have M equal to 2 and C equal to 32, right? And K equal to 128, right? Okay, so then, not yet. So we have the formula, right? Come on, come on, come on, come on, come on. Oh, did not work. Okay, let me write down. Come on, did not work. Okay, so let me write down here. So we have M y double prime plus C y prime plus K y equal to 0. Then M equal to 2, C equal to 32, K equal to 128. And y second prime plus y prime plus y equal to 0. Okay, so we can express this one as 2r squared plus 32r plus 128 equal to 0, right? Okay. Then what is the general solution form of general solution, right? So let's take a look. So general solution of critically damped, right? So in that case, like that, right? Yeah. Okay. Okay, so R is easy. Let us do that. R equal to R sub 1, R sub 2 equal to negative C over 2M, which is C is negative 32 over 2, M is 2. So what do you get? Yeah, it's negative 8, right? Okay, general solution will be y equal to e to the negative c. C is negative 32 t over 2m 2 and c sub 1 plus c sub 2 t, right? Okay, that will be y equal to e to the positive 32 t over 4 c sub 1 plus c sub 2 t. That's the general solution. Make sense? Okay, now second part. So we want to find the displacement y for t is greater than 0 if the motion is critically damped. So let me writing out critically damped. You might not realize that. Critically damped. And the initial conditions are y of 0 equal to 1, y prime of 0 equal to 20. Okay, so let's do it. We have, let me see. Okay, so let's clear about this one. We can, wait a minute. Is it positive 32? Is it correct? Okay, let me double check here. Because we have a negative, right? So negative, but then we have a C equal to, this is a C, which is positive 32. So negative 32, right? But then the form is e to the negative ct. So we have negative, negative is positive, right? Okay. All right. So let me finish this one and then let me double check because the sign is different. Y equal to 32 divided by 4, which is 8, right? So e to the 8t. And we have c sub 1 plus c sub 2t. Yeah. Okay. Okay, so sign is not right. So I double checked. So where I made a mistake here. Okay, so let's take a look one more time. So we have r sub 1, r sub 2, which is the root, right? So give us the formula, negative c over 2m, right? Okay, then c is 32. So we are using that, negative 8. That is a root. Yeah. Okay, now the general solution is e to the negative ct. So we're not double using negative 32, right? We have a negative there. What's the c? C is just 32, right? C is just 32. Make sense? So I was looking at here, negative 32. It should not be here, right? So C itself is a 32, right? But we have a negative sign, right? So we can use this root here too, right? So same as this one, right? Make sense? So we're using negative 80 basically. Yeah. Okay, now, so there is minor mistake. So negative 32, then this one should not be there. You guys okay, right? Yeah, understand? Um, okay, let's move on then. What we are doing right now. So we have, hold on 1 second. We want to find the system 1, system 2, right? So we have let me just copy this one, general solution. Am I recording? Yeah. Copy. General solution, right? So we have a general solution. Okay, now what about the derivative, right? So if we have a derivative with respect to t, so there will be product rule. So f g, right? So f prime g plus f g prime. So we will get f prime So e to the negative 8t times the negative 8, right? So negative 8 e to the negative 8t. And g, c sub 1 plus c sub 2t. And plus f, which is e to the negative 8t, g prime. So inside the prime, so constant 0 and just constant c2, right? C sub 2. All right, then let's do that. Y of 0 equal to 1, you use initial conditions equal to e to the negative 8, 0, c sub 1 plus c sub 2t, which is 0, right? Okay, now second term is 0, so we have c sub 1 e to the 0 power, which is 1, right? So there will be c sub 1 equal to 1. Okay, we have a second one, y prime of 0 equal to 20 equal to, using this one, so negative 8 e to the negative 8, 0, c sub 1 plus c sub 2, 0 plus e to the negative 8, 0 times c sub 2, right? Okay, now 20 equal to negative 8, it's 1, and c sub 1 plus, it's 1, so c sub 2, right? Okay, so there will be 20 equal to negative 8 c sub 1 minus 8 c sub 2, right? But then we knew c sub 1 equal to 1, so 20 equal to negative 8 c sub 1 equal to 1 minus 8 c sub 2, so we will get c sub 2. So it will be 28, negative 8, negative 8 c sub 2 equal to positive 28, right? Okay, then sign. Did I make a mistake? Sign again. So let me double check the sign again. Hold on 1 second. Okay, I'm very sorry. I knew where I made a mistake here. So let's take a look. This is 0. This is c sub 1. This is another term, right? So I did not put the parentheses here. Make sense? Okay, so that will be c sub 1. Ooh, yeah. So there will be c sub 1 and then c sub 2, right? Okay, sorry about that. I apologize you. I don't want to make you confused. Okay, so there will be, then we don't have a, no distribute, just positive, right? So positive. So there will be positive. Okay, then c sub 2 equal to 28 then, right? Yeah, clear? All right, now we find c sub 1, c sub 2, right? So there will be, from the general solution, we find the particular solution. In that case, is displacement. So we have y equal to y over t actually, right? Equal to e to the negative at. C sub 1, which is 1, plus C sub 2, which is 28t, right? So this displacement in feet. Yeah, clear? Okay. The last questions, no, not last question. We have one more for this one. Okay, so consider the force damped oscillator equation. Okay, we have this form, right? Okay, so we have, or we are trying to do, we trying to find what's the omega. Yeah, so, okay, so this is omega, right? All right, so what is omega? So don't get confused with the weight W, right? So this is omega. So we called angular frequency. Okay, then did we have formula before? Omega? Okay, we don't, right? So only this one, omega in the case, omega sub 1 is this one, right? All right, then, yeah, in the case, yeah, they don't give us the omega in the case. All right, so let us use in the case omega angular frequency. So omega equal to square root of k over m. Okay, in that case, square root, what's the k is 16, right? We're using just coefficient. M, C, K, right? So we don't have a C there. So just M and K, right? So K is 16, M equal to 1, which is 4. Yeah. Or we can use other method, right? So if we have y double prime plus 16y and equal to 0, then we can express as r squared plus 16 equal to 0, right? Then we can find r squared, r equal, r equal to, it's a plus minus 4i. Yeah. Okay, so that is omega, right? We knew that, right? So that is omega. Yeah. So we can find omega by this one, like a previous method, right? And this is a new formula for this section, angular frequency. All right. Okay. So we have the vocabulary resonance, which is resonance. How pronounce resonance? The quality in the sounds of being deep. Yeah, deep. So we have that. Okay, let us do one more theorem. Then one more question, then we are done for this section. All right, so we have a theorem. So we have the format equation. It's here, second linear order, right? Okay, then we have omega equal to omega sub max. So angular frequency, we want to find the maximum, then we have this formula, yeah? So K come from coefficient, M come from the coefficient, right? M, K, C there, yeah? And then they said, what is F sub 0 or F naught? That is the amplitude of the external. We learn about the sinusoidal function, right? So sine function, cosine function, we have a fancy word, sinusoidal functions, right? So in that case, sinusoidal force, it's about the cosine function, sine function, all right? Okay, so we have this question, and that will be last question for this section, okay? All right, so we want to find resonant frequency, which is angular frequencies, which is omega, right? So in that case, we want to find maximum of angular frequency. So I brought the formula here. Okay, now, uh, and everything is given, right? So it's mass 3 kilograms. So we notice that M, yeah. And then spring constant of 8, which is K, right? And damping, whose coefficient is 3. And S means Newton seconds, yeah. So there will be C then, yeah. This will be C. M. Okay, so let's make the format. We don't need this, right? But let's write down. So M equal to 3, Y second prime plus C equal to 3. That's the damping force, right? And Y prime plus K spring constant, which is 8. Y equal to F naught cosine omega T, right? Okay, so we want to know about angular frequency about the max equal to square root of, I should not. Okay, K over M, so this is M C K. So we will have 8 over M, 1 minus C squared, 3 squared over 2K M. Okay, now, can you please calculate everything? Okay, so you got, what do you get? 1.15? Okay, all right, thank you very much. So this is maximum of the angular frequency with a mass 3 kilogram and the spring constant of 8. And then damping coefficient is 3. Yeah, okay. Thank you for watching. Bye.